So in this problem, we would like to find a potential function, in other words, a scalar function for the conservative vector field f of xy is equal to 2xy plus sine x, comma, e to the y plus x squared. So what do we need to remember about this problem? When you have a conservative vector field like this, and you know it's conservative because you have checked the compatibility condition, so you have p of xy and q of xy, and you know that the partial derivative of p with respect to y is equal to partial derivative with respect of q with respect to x, then what you want to do, which we should say here, that's not sufficient, it's locally sufficient. You need to have, if you want to be able to have a potential on a much larger domain, then for example, you need conditions such as the simple connectedness of that domain. But in any case, we're not going to encounter any such complications in the simple problems that we're dealing with here. All you need to do is take phi, the potential, to be the indefinite integral of p with respect to x. And what you need to remember is that once you find the answer, just put plus g of y, because since you have a function of two variables and you're integrating with respect to x, then any expression of y, when you differentiate with respect to x, disappears, so it can serve as a constant. Which means that in order to find the specific expression of y that you need, you will need to make sure that what you found checks out for the second component, meaning that the derivative with respect to y is equal to q. Okay, so this will enable you to actually identify g. Let's see how this is done on our example. So we will take phi of xy to be the integral of 2xy plus sine x dx, and we will simply find here x squared y minus cosine x. And instead of putting, that's the antiderivative of sine, and instead of putting plus c, we will put plus g of y. So now we need to require that the partial derivative with respect to y of what we just found, we already know that the partial derivative with respect to x is the first component. We have to make sure that the partial derivative with respect to y is the second component, meaning it's e to the y plus y squared. So what is the partial derivative with respect to y of what you have on the left? It's going to be, this is x squared. So it's going to be x squared plus g prime of y, and you want this to be e to the y plus x squared. The x's go away, and pretty much you're left with g prime of y being equal to e to the y. That's exactly what would have gone wrong if this was not a conservative vector field. You wouldn't have found an expression that depends on just y, or you may have had further complications on finding an integral here. So different things could go wrong. But here, if you want a function whose derivative is e to the y, then this function can be chosen to simply be e to the y. So now we can finish by asserting that the potential is x squared y minus cosine x plus e to the y.